Hello, this is Mr. Reese, and this video is going to focus on the area of parallelograms. Before we get started, what I want to do is kind of derive where the area formula comes from, and then what we'll do is we'll do some examples. Let's say we've got this rectangle here, and by the way, there's a slice here that's kind of cut off. If you were to take this rectangle here and kind of remove the piece, you should have the understanding that these two pieces together still add up to the same whole area of a rectangle. That being that the area is equal to the base times the height, or length times width. The rectangle formula comes from your multiplication chart, which you learned like back in elementary school. You may recall that your teacher told you to fill in a multiplication chart by writing numbers across the top and then vertically, and then you would fill in the spaces in between. So for example, if you wanted to know, say, 5 times 2, you would trace it to here and write in 10. Well, while you were doing that, you were also determining the area of a rectangle. You see, this rectangle has 10 squares in it. Or say 3 times 4, which is 12. The resulting box gives you 12 squares. So that's how the area of a rectangle evolved. Essentially, right here, that's 3 for the base, and then this is 4 high, so 3 times 4 would give you that. So let's go back to our rectangle here. If you were to take this triangle here and remove it, it's still the whole area is still the same. You can move it wherever you like. Adding these two together still gives you the same as the base times the height for a rectangle. If you were to take this and move it over here to the end, what you should realize is that what we have is a parallelogram. And a parallelogram, you'll notice that it has the same area because of the fact that we're still dealing with the same two pieces. Because of that, the formula for the area of a parallelogram is the same as it is for any rectangle or square. That is, its base times height. Therefore, if you were going to get a figure like this to determine its area, all you would need to do is just simply count the base here. There are 7 squares on the bottom, and then its height. Its height, no matter where you draw it, I'm just drawing it here in the middle, is 4 units high. Again, that is, the area is the base times the height, which is 7 times 4, which gives you 28. Also, mind you that if we were to take this triangle here and we move it to the right hand side, you'll notice that the base is still 7 and the height is still 4. So again, that's the reason why the rectangle formula works for all parallelograms as well. Let's do an example. Let's say you were to determine the area of this parallelogram. First, write the formula. It's a good idea only because with the use of the formula, if you write it for every single problem, it's going to help you with your studying because you will already have the formula ingrained in your memory. Now let's go ahead and plug in our given values. You should note, and this is a key idea, that the base and the height always form a right angle. So if you're seeing the right angle right here, you'll notice that that right angle is formed by this segment and this segment. So those are the two measurements you use. You'll notice that we still have a, so that's the variable we're going to solve for. Just do your multiplication here, and then you get your solution. And that's all there is to it. Note that the units are inches squared because we have inches. The little 2 is to denote that we had 2 inches, 2-inch units rather, multiplied together, so inches times inches is inches squared. You might also recall in our previous problem we were counting squares, so that's the relationship there. How about another example? Let's say we were to determine the area of this figure. As before, we want to write our formula first. Now let's plug in our given values. Recall that it is the right angle we want to focus on. That tells us where our base and our height are. So if our right angle is here, that means this length and this length are the base and the height. So you should see that base does not necessarily mean bottom, and height does not necessarily mean how tall in this particular case. It's a misnomer. It is the reason why some people will use the terms length and width. What happens is that the height is actually supposed to be just the space between the top and bottom, or rather I should say the two bases. There are technically two bases. So that will be 12 times 25. And now we just go ahead and solve. Just multiply these two units together, and we get our solution. By the way, the little mark here means feet, so that would be square feet here that we have at the end for units. Notice that we did not use the 30. Again, we only focus on two particular measurements, the base and the height, which form the 90-degree angle. Okay, let's do another one, but this time with a little bit of algebra. Let's say we determine whether we have the area already determined. Now let's solve for an unknown variable. There's step 1. Recall that the right angle tells us where the base and the height are. So that's going to be x plus 5 times 8. Now when we write this, we don't write it like this, x plus 5 and then times 8, and then think 5 times 8 is 40. We use parentheses here in this particular case to group the x plus 5 together. So this way 8 is being multiplied to the entire group. So in solving for the variable here, we're going to distribute the 8. So that's 8x plus 40. And then subtract 40. Then divide 8. And that is our answer. Okay, let's do one last one here. Let's solve for x again, but this time with a lot more information available. There's our formula first. Now what we're going to do is we're going to try to determine the area first instead of just solving for x right off the top. Recall that the key idea is that the base and the height form a right angle. But you note that there are two right angles in this particular case. We have this one down here with the numbers 6 and 5 matching up. We also have this one up here. So since we can get the area real quickly from 6 and 5, we'll just simply use that for now. Multiply and you get 30. So the area for this figure is 30. Now here's what we're going to do. We're going to disregard this 6 and 5 here. And what we'll focus on now is just the 8 and the x. I want you to note that this distance here can be drawn anywhere essentially. So if I were to draw this so that it's inside, maybe it's a little more clear now. This 8 matches with x. In other words, this would be the base and this would be the height. We already have our area. So let's go ahead and do this again. There's our formula. Those are the values to plug in. A is 30 because we've already solved it. The base is 8 and the height is x. And then we just go ahead and solve by dividing 8. So that's our answer.